All right, let's go ahead and begin on section 6.5, properties of logarithms. We're going to split this up into 2 days, so here we go with part A. In the first part right here, we're going to take a look at properties of logarithms. And there's three properties here. Make sure that with these three properties, you got to memorize them. Okay, know them. They're pretty simple. With the product property, what they're saying here is this. If I have log base of b times mn, that is the same thing. I could rewrite my expression as log base b of m plus log base b of n. So product property, think, hey, we're going to add the logarithms together. Okay, and that's, think about, it's the same thing as what you would do with exponents, right? If the bases are the same, what do you do with the exponents? When you're multiplying, you add the powers. So maybe you could think about it something like that, of that nature. So with the quotient property, if you think about what I just mentioned, then the quotient property is, hey, I want to be subtracting the powers, right? If we were dealing with exponents. So with our logarithms, we have log base b m over n. That's going to be equal to log base b of m minus log base b of n. So quotient property. And then right here, finally, we have the power property. And when you think about the power property, when we raise a power to a power, we end up multiplying things together. Now, that's not necessarily the case right here. What you hopefully see is that our exponent is n. And what ends up happening is that drops in front of the logarithm and becomes n times log base b of m. And that is what they're trying to show you in the power property for our logarithm. Okay, so we're going to just deal with this section right here, or this core concept. We'll come back to the change of base come day 2. So with that, that'll help us evaluate these logarithms. Now, they give us right here log base 2 of 5 is equal to approximately 2.322. And log base 2 of 12 is approximately 3.585. So what we have to do is use that information to try and solve something like number 1. But in number 1, there's nothing that has 5 and 12 in it. So this is where we use our product properties, or our quotient or power properties, to try to help us to solve these problems out. And we got to get creative here. And hopefully you see with that 60, I can go ahead and rewrite it. Right? By using the power property, I can go ahead and rewrite this as log base 2. And then how can I get 60? Well, one way I can get 60 is by taking 5 times 12. Why am I choosing 5 and 12? Because up in the problem, they give us right here log base 2 of 5 and log base 2 of 12. They give us information of what that equals. So you guys need to know how to do this. Especially, you might, maybe you have a calculator that can plug in logarithms, and you say, hey, I can get that answer. Well, a few things. I could change the numbers to where log base 2 of 5 is equal to like 2.57. I could change it. So if you don't know how to do if you don't know the properties correctly, you're not going to get the right answer. Maybe in a calculator you get the right answer, but not based off of what I'm giving you here in the information. So it is critical that you do know how to use know the properties. Okay, you guys always try to find ways to, little shortcuts, or say, hey, I could just use a calculator. Hey, I have tricks up my sleeve too to be able to test you guys on these. So let's go ahead. If we use our change of base, or sorry, our product property, When we're multiplying, we could also go ahead and change this. It's the same as adding things up. So I'm going to go ahead and put this as log base 2 of 5 plus log base 2 of 12 by using the product property of logarithms. And so now that I have that, I can go ahead, it looks like exactly at the top of the question now, and I will go ahead and substitute things out. Log base 2 of 5 is now equal to 2.322. Log base 2 of 12 is 3.585. And then you can go ahead and plug all that stuff in together, and we get approximately 5.907. And typically they do want you to round to the thousandths here in this section when we're dealing with these logarithms. So go ahead and make sure you do that. All right, so let's go ahead and continue on with number 2. I see right there that we are dividing. I got log base 2 of 1 over 144. So remember, when we are dividing, we're going to be that's the same as subtracting the logarithms together. So let's go ahead and start off first by, let's rewrite this. So I can go ahead and rewrite this as log base 2 of 1 minus log base 2 of 144. All right, I look and I see right here, I need log base 2 of 5 and I need log base 2 of 12, and I don't have any of that. Well, let's see. Can I change any of these where I can rewrite it? And right there, I can't. Let's look at this log base 2 of 144. Somehow I could change that 144 and get myself a base of 12. And how about change that to an exponent of 2 or 12 squared? So let's go ahead and start off right here. Log base 2, instead of 144, I'm going to go ahead and rewrite that as 12 to the second power. And when I have 12 to the second power right there, hey, I do see a log base 2 of 12. All right, so that will allow us to take care of that. Let's go ahead and start simplifying things out. But before that, there's one other thing I could do right here with that log base 2 of 12 to the second power. Remember, we talked about the power property. And so this exponent right here of 2, I can bring that down to the front of the log 2. So let's go ahead, and I'll rewrite this as 2 times log base 2 of 12. All right, so but then what do I do with that log base 2 of 1? Good question. There's nothing there that looks like I could change 5 to a 1 or 12 to a 1. No way. But think about this. How could I rewrite this logarithm as an exponent? All right, so let's rewrite this. And so if I do that right here, I'm going to end up with 1 is equal to 2 to the x power. Well, think about this. What could I plug in for x that will get me to equal 1? And that's going to be 0. 2 to the 0 power is equal to 1. So this log base 2 of 1, that's going to simplify down to 0. And then right here, I've got 2 times, let's go ahead and change this log base 2 of 12, and we'll change that, rewrite that as 3.585. And then I can go ahead and simplify all of this together. Okay? And so what you were going to end up right here ends up being negative 7.17. And there's our solution for number 2. Let's do some more questions to get you the hang of things. All right, I'm going to go ahead and erase this. Get some more space here. Let's take a look at number 3. All right, so I've got quotient. So let's go ahead and we'll use our quotient property here. And so let's take this and rewrite it as log base 2 of 12 minus log base 2 of 25. All right, so log base 2 of 12, I could already substitute that in. Easy peasy, because it's already given to us up at the top. But this log base 2 of 25, well, maybe I could substitute that into log base 2 of 5 somehow. And if we can go ahead and change this to, instead of 25, change that to 5 squared. So we have log base 2 of 5 squared. We use now our power property, so let's go ahead and bring the 2 out in front. And so it's going to be 2 times log base 2 of 5. Let's go ahead and now substitute in our numbers right here. Log base 2 of 12, we already know that that is 3.585. And then 2 times log base 2 of 5 right there. Let's go ahead, we got 2, and then I'll put in parentheses. Log base 2 of 5 is 2.322. And then we can go ahead, you can use your calculator and plug all that in and get our solution, which is negative 1.059. All right, there we go, right there. All right, let's go ahead and try the last one, number 4. We got log base 2 of 720. So maybe, what can we do right here? How can I split things up? Think of different factors that get us 720. Maybe some of those factors have 12 in it and a 5. It's probably going to have to. Okay? Give you a moment to think about that. And so there's our moment. You could have paused it maybe. Right here, think, what are some factors of 12? 12 times 5 isn't going to get me 720. So think, what are some other factors of 12? 24. Can I get 24 times 5? No. Then after that, kind of go down the line, 36, and so on. Ways that I could maybe even get, think about how we did like number 2 and number 3, where we rewrote things from like log base 2 of 25, and that became 5 squared. Or on number 2, we got log base 2 of 144, we used 12 squared. In this one right here, if you're saying, hey, why don't you cut to the chase, Mr. Kim? Well, I do want you guys to try to put some thought into it. How about 144 times 5? That right there ends up equaling 720. Why did I choose these? Well, first off, let's go ahead and rewrite some stuff. This will become, so since we're the product property, we got log base 2 of 144 plus log base 2 of 5. Because now, with that 144, I could change that to 12 squared. So we got log base 2 of 12 squared. And then let's go ahead and bring that 2 up to the front. And so it's going to be 2 times log base 2 of 12. And guess what? We have something in our problem that tells us what log base 2 of 12 is. And that right there is 3.585. And then we have log base 2 of 5, which we know is, what is it? It is a plus, and then 2.322. So now we have all that together. we can go ahead and simplify this out to get your final answer. And our final answer right here, after you have your order of operations, we got 9.492. And that's an approximation. All right, so we now have done the first 4 problems. You can see, look, it's not straightforward. You do have to put some, put that brain to use. Think of some of your products. Maybe use your calculator, start multiplying things out. Think of exponential, factors and so forth to try to help you get your answer here. All right. So we have now evaluated logarithms when they gave us certain information. So now let's go back. Let's check out these next few problems. Number 5. We're going to expand the logarithmic expression. Okay, so we, in a sense, kind of condense things together. So now we're going to expand, and we're going to have to use our properties of logarithms here. Well, right here we have log. Now, there's no base, so that automatically means it's base 10. So we have log base 10 of 10 times x. So remember, if it's 10 times x, we are going to be using the product property. And so we have ourselves log base 10 of 10. And then product property is we're going to add things together. So it's going to be plus log base of x. There you go. Now, there is something here that you do need. We haven't completely simplified this, because don't forget, this is log base, and when there's nothing there, it's log base 10 of 10. When the base is the same as what it is of, remember, what does that equal? That equals 1. So we can simplify this some more and change this to 1 plus log base 10 of x, or just your natural log. And that is its most simplified answer. All right. Next up, number 6. This is where things get a little tricky. Okay, we have ln, and then we have of 2 times x to the 6th power. Now right here, what we want to do is, one of the things we talked about is, hey, how about we take that 6 and bring it out to the front? But when we're expanding the logarithm, we don't do that in the beginning. So here's what we're going to do first. Let's go ahead and rewrite this. We're going to expand it out. So ln 2, and then since we're multiplying, we're going to go ahead, remember, use our product property. It's going to be plus, and then ln x to the 6th power. Okay, so we're going to split it apart first using the properties, and then we use that power property next. So we have ln 2 plus, and this is going to be 6 times ln of x. And that right there is how we use our properties to expand this logarithm. Okay, so the rules, think of it like order of operations. And right here, we have to split it apart first before we deal with those powers. Okay, so let's go next to number 7. All right, so right here in number 7, we have looking at the quotient. So let's use that quotient property. And then we have log base 3 of x to the 4th power, and then minus log base 3, and then we have 3y to the 3rd. Okay. So we've got several things that we got to now worry about. Okay, first off, we used the quotient property, and now from here, let's use this power property to help us simplify things some more. All right. So what can we do next? With the first part, log base 3 of x to the fourth, let's go ahead and use our power property. I'll put the 4 in front, and then 4 times log base 3 of x. Now, if we look carefully right here with the second part of our expression, we've got log base 3, and then we have 3 times y to the third. Okay? And so there's some more steps right here that we could take to this problem. Think about it. Right there, we do have, let me choose a different color. If we look right there, that 3y to the third power, I can go ahead and rewrite that. Because think about it. That's multiplying. We got ourselves product property right there. So let's go ahead. I'll expand that part out. And right here we have a minus out in front. And then let's go ahead and put right here log base 3 of 3. And then we're going to have right there, since it's multiplying, it's going to be plus log base 3 of y to the third. Okay, we're almost done with this. So let's put a few things together. So I have log, or 4 times log base 3 of x. Okay, and then let's go ahead, we're going to distribute that y. So that'll get us minus log base 3 of 3. And then we also need to make sure that we take that minus sign to the next term. But also, we have to bring that third power out in front. So this will now become minus 3 times log base 3 of y. And that right there, my friends, is our answer. We have now put it all together. Okay, so there's quite a few steps and work right here for this problem. All right, so once again, to recap this section or this part, I took the initial log base 3 times 3y to the third, okay, and then I made sure, hey, I had to split this apart, but before I could use that power property, I went ahead and used the product property again to split that term apart, and I put that right there in blue. And then I went ahead and had to use that power property again for that last little section, that log base 3 of y to the third power. And then I had to make sure that I carry that sign along. So that was like a mega mix of all the different steps combined right there all in one. All right, let's take a look next up at number 8. Let's see what we could do right here. I've got ln, and then we got the fourth root. So we haven't really dealt with radicals so far when it came to this, but hey, not a problem. Let's go ahead and rewrite this. That in radical form, let's go ahead and change that to an exponent, and that's going to be to the 1/4 power. Okay, so that right there, pretty straightforward. Let's go ahead next. Let's bring down that exponent. Okay, so using the power property, we now have 1/4, and then we have ln of 3y squared. Now, let's go ahead, since we could use the product property 3 times y squared, let's go ahead and do that right here. And let's change this. We have 1/4, and then I now have ln. And let's use different colors here to kind of maybe make things a little clearer for you. ln of 3, and then plus ln y to the second. Okay? We have ln y to the second. Now, I think right here it'll make a little bit easier. We have that 1/4 out in front, and it's 1/4 times all of this action that we're just dealing with right here. So we have that now, and so let's go ahead Um, we're going to bring down that 2 out in front of the ln y squared. So let me go ahead right here. I've got 1/4. I've got ln 3 plus 2 times ln y. And the last thing you could do is simplify this a little bit further by distributing that 1/4. And so this answer is going to be 1/4 ln of 3 plus 2 times 1/4, which ends up being 1/2 ln of y. And there you go. We finished up the first part of 6.5a. So in this section, we had a lot of things go on. They all dealt with the 3 properties, right? We had our product, quotient, and power property. And you also have to kind of use like an order of operations in order to correctly use them in expanding or condensing, which we'll get to in 6.5b. Hope you learned a lot right here.